So now we're gonna have two types of graphs. This is the first one, growth models. All right, so this is what we need to know for growth models. You can see that one is going up to the right, one is going down to the right. So what that means is we need to know what this arrow stands for right here. Anybody know what this arrow is? What is this?
But what is what called that? That's the
Yeah,
y-intercept, right?
right, exactly. That's the y-intercept. Like, this is the y-intercept, but C, normally you would think, okay, that represents the y-intercept, right? Because we're used to seeing C in those, equations at the
No,
end, number by
no.
itself. But
Don't
actually what this
interrupt.
represents is our asymptote. That's our asymptote. So it's going to be this little line right here. This is C. It's what this graph never crosses. This is y equals C because it's a horizontal asymptote. And the way we get our y-intercept is we say, all right, we know if it's the y-intercept, x equals 0, but the y value equals k plus c. So c is part of the y-intercept, not the whole thing. So it's whatever k is here plus c. And so when k is bigger than 0, you can see here our domain is going to be negative infinity to infinity. Or if you want to get fancy, you can say all reals. For our range, because we have a, what do you call this thing, an asymptote here, our range is here. I'm trying to look at the chat. So our range here, we're looking at up and down up here. So you see, we can't cross our asymptote here. So we're starting there. We're starting wherever asymptote is. So it's going to be C, and then it goes up to infinity because it's growth. And behavior. You should remember this from Algebra 2, but that was a little long time ago for y'all. As x goes to infinity, you'll see that y also goes to infinity. So as x goes to infinity, y goes to infinity. What about the other side? As x goes to negative infinity, that's what I meant. What happens to y? Y actually approaches C because we don't cross this line. So y approaches C. Now for this growth, same exact thing, except we're going down the other way. So if you notice, if I said the same exact thing, again, it's a y-intercept, so it's 0 something. Well, since we already have k representing being less than 0, we don't have to write negative here. We can just say it's the same thing, k plus c, because k is 0. That's what it says right here, less than 0. It's already negative. We don't have to put a negative here. So then the domain, actually, I'll do the asymptote again. And then on the flip side, it's the same exact thing. Now my k is negative. K is negative, which means that it's flipped over. So now what I say is end behavior. I'll do this first. End behavior. When x is increasing, as x goes to infinity, you'll notice that now my y is going down this way. Y goes to negative infinity. And if I'm going the other way, as x goes to negative infinity, now y is approaching c again. Now for the domain, as you can see, left and right, it's covering all values on this x-axis. It covers all the values here, all values this way. So again, it's all reals. So I can say negative infinity to infinity or all reals. For the range, now I'm under my asymptote. So I'll say, okay, all these values down here, all these values I have down here for y, but then I don't go past this line here. So it'll be from negative infinity, and then I get up to c and I stop. Right. But you always do the smallest thing first. So it'll be negative infinity to c. Always small to big. And if anyone's wondering about these little symbols here, all that's saying is that a has to be a positive rational number. Q means rational, which means it can be made into a fraction. That's what this means here. So k is going to be your multiplier. I'll do another color for that. So your multiplier is right here. This is k. So for example, if my equation was f of x equals 2 to the x, here k equals 1, my c equals 0, and my a equals 2. But if I have f of x equals 3, 2 to the x plus 1, then k equals 3, a equals 2, c equals 1, like that. No, no, no. I don't have the proper tools for real nice handwriting. Like, your handwriting is 80 times better than mine. So yeah, so if I wanted to find y, so for example, if I have this equation here and they say x equals 10, I plug 10 in right here, and then I give me my y value here. So 0 k plus c, that's your y-intercept. So for example, in this problem here, in this one, your y-intercept would be 0 and then 3 plus 1, which will be 0, 4. I think that's what you're talking about. Because if you see, if in this one here, my c is 0, so that means my y-intercept is going to be 0, and then since I have 1 here, the 1's in front of the 2, 1, like that. Anytime you don't have a multiplier there, you always assume it's 1. And then you plug in x to find different. Yes, exactly. Again, here, the same exact concept, except now we're decaying models. So think about somebody's bank account. I'm not going to put anybody on blast, but some people have bank accounts that just continually decay. I told them stop buying all those shoes. So again, this is your asymptote. So it's like this. That's y equals c. Your y-intercept, so that's 0, k plus c. So if you see that, it's just modeling the same exact things. Nothing's really changing. So here, this one, k is greater than 0. That's why it's on top of the x-axis. So the domain would be, again, all reals. The range would be, it goes from c here to positive infinity.
Can't you just do that R with the extra line?
Yes, exactly. So for this, you can also write this as this. Yeah, that means all real.
Okay, because I found that a lot easier than the having to write infinity signs.
Yeah, good thing about IB is they don't care how you write it as long as it makes sense. And then the end behavior here is a little bit different because it's flipped the other way, it's decay. So as x goes to infinity, so as x is doing that, y goes to c. As x goes to negative infinity, this way, y actually is going to positive infinity. That. So I don't know, do you guys need me to go over the last one, or do you understand this concept? I don't care. I'll do it anyways. Yeah. So here again, I have my c here. That's y equals c. K is negative, so this is negative. So that's why it's going down below the x-axis. So again, as you can see, it's still going this way and this way. So the domain is still, I'll write it like Rawala wants me to do it, like that, all reals. The range now, since it's under C, it would be under the C. Okay, I don't know why I said that. So the range goes from negative infinity to C again, to C. There we go. And behavior as x goes to infinity. So as x goes this way, y just approaches C. You see that? It's not going to cross that line. As x goes to negative infinity, as we're going down this way, x is going this way, y is going to negative infinity. Yes, we always start with when x is going to positive infinity, and then you do when x is going to negative infinity. So when writing an end behavior, I'll put that up here. When writing end behavior, we say first start with x goes to infinity. What happens to y's? Then you say when x goes to negative infinity, What happens to the y's? This is end behavior.